Okay, welcome to chapter 3, section 2, where we're going to get a little bit more specific with lines and their transversals. So what I need you to do is turn to page 132 in your textbook and copy down theorems 3.1 to 3.4. So you're probably going to pause and do that, and then come back to me, and we're going to do some stuff together. All right, so you should have copied down theorems 3.1 to 3.4. Important to know their names. We're going to use them. I am going to do a lot of examples actually on this video, especially number 1. You are eventually going to do number 2 just to practice, right? So let's get a good idea about what those theorems actually are. So all we need to do is draw 2 parallel lines, because things are actually easy to define when we have parallel lines. So let's draw 2 parallel lines, and as long as we put a line through them, we can call it a transversal. Okay. All right. Now, you can see in the book, they numbered the angles like so. This is next to those theorems. So let's go ahead and let's just identify the angles that go with the different theorems, okay? So first we have the corresponding angles theorem. So this is theorem 3.1. You probably should write all the words down. In the interest of time, since I'm doing the video, you can pause it. You can write this down. I'm going to just make sure you know where to look. So these are corresponding angles. So if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So that means they're equal to each other. So we're looking for angles that are going to be equal to each other. So let's start with number 1. Number 1, this is how I kind of look at it. Angle 1 is, it's like at the top left of its intersection, right? Here's its line and its intersection, its transversal. So what's the corresponding angle down here at this intersection? It would be angle 5. These are corresponding angles. They are congruent. Likewise, angle 2 is at the top right of its intersection. Angle 6 is at the top right of its intersection. Keep in mind, if these are 2 roads, this is the intersection. Okay, so angle 6 is the top right corner. Okay, and then likewise, angle 3 is congruent with angle 7, and angle 4 is congruent with angle 8, all by the corresponding angles theorem 3-1. All right, but that's not the only pairs of congruent angles that we could come up with. So let's do theorem, or let's look at theorem 3.2. This would be alternate interior angles. All right, so if you're confused about what's interior, then I need you to cover up the topmost and bottommost angles. Those are outside. So what's interior? What are the inside angles? 3, 4, 5, and 6. So let's start with angle 3. Angle 3 is right here. Alternate interior, okay? Bottom left of its intersection, alternate interior, top right. Bottom left, top right, alternate. Both of them are also interior. I also like to think about it's hopscotching right over, hopping over, okay? Angle 4 is congruent with angle 5. Now, look, you can't actually go by sight because figures are not drawn to scale, especially if we're drawing them as humans, but this looks like the smaller angle from 3 and 4, the 2 supplementary angles, right? Add up to 180 on a line, 3 and 4. So angle 6 is going to be the congruent one, right? It's going to be the congruent one. All right, so that would be your only 2 pairs of alternate interior angles. So let's move on to theorem 3.3. Which would be alternate exterior. So you don't know what exterior is, those would be on the outside. Take your finger, cover up the inside. We should be only looking at angles 1, 2, 7, and 8. So let's start with angle 1. alternate exterior, has to be on the outside. Angle 1's at the top left, alternate bottom right. These are congruent. Angle 2 is congruent with angle 7, top right, bottom left. All right, these would be your alternate exterior angles. Remember, exterior, they're outside. Give yourself the benefit of the doubt, cover up the interior. Okay, and now the one theorem that kind of doesn't belong. These are all congruent. Theorem 3, 4. All right. Theorem 3, 4. Consecutive interior angles. So consecutive interior, they have to be interior. Consecutive, they kind of have to be in order in some way. Now, we obviously know angles 3 and 4 are supplementary, right? They put them together, they equal 180, they form a line. Angles 3 and 4 are supplementary. Consecutive interior kind of takes alternate interior, angles 4 and 5 are congruent, and flips it. If angles 4 and 5 are congruent, are the same measure, then angles 3 and 5 together add up to 180. So measure of angle 3 plus the measure of angle 5 equals 180 degrees. Consecutive interior. Here's the consecutive part. If you're just going this way, 3, then 5. 1, 3, 5, 7. But 1 and 7 are exterior. So consecutive interior, 3 plus 5. 3 and 5 is 7. 3 and 5 is 180. And the measure of angles 4 and 6 are equal to 180 degrees as well. Okay, all right. That kind of breaks down all the stuff in the boxes. It's important to see it, hear it again, look at it maybe in a different way. And I'm actually going to go do an example that's in my book and not yours. So what do we have? You know what? Let's go to Greek. Let's call it letter alpha. If it's in a Greek letter, we're not going to find it in our book. All right. You're going to find it in my book if you have the teacher's edition, but you're not the teacher. So we're going to draw 2 parallel lines. Oh, and there's one important thing I forgot to do in my notes. We're going to draw parallel lines P and Q. How do we know they're parallel? We have to put arrows going in the same direction. Do that up there in my notes. Add them over here. Okay, parallel lines. And we're going to have a transversal that we're going to call T. Okay. Now, they're going to tell us that this is angle 1, this is angle 2, this is angle 4, 5, 6, 7, 8. What did I skip? Angle 3 is 75 degrees. All right, so here's the thing. What other angles are also 75 degrees, and what theorem, not the number, the actual words, what theorem are we using? So find the other angles that are equal to 75 degrees. Well, let's use vertical angles. Angle 2 is equal to, oopsies, we don't need the congruent, we can just say equal to 75. The measure of angle 2 is equal to 75 degrees. These two are vertical angles, right? Vertical angles. All right, 75, and let's do angle 6. Measure of angle 6 is equal to 75 degrees. What would the theorem be? This would be alternate, because I'm going from left to right, alternate inside, interior. So I'm going to write alt, int. Okay, and then finally, what one other angle is also 75 degrees, that's going to be angle 7. And I'm going to say that since this is at the bottom left of its intersection and this is the bottom left of its intersection, that would be the corresponding angles theorem. Okay, and obviously I'm using shorthand here, vertical, alternate, interior, corresponding. For vertical angles, alternate interior angles theorem and corresponding angles theorem. But those are the three other angles that are 75 degrees and my reasoning in shorthand. Okay? All right. Now, let's take a look at example. Actually, you know what? I'll do another one of my own. So this is letter beta. It's a B, capital B, with a line that's going a little farther down. What if I asked you to draw me two parallel lines, a transversal, transversal T. How do I know these lines are parallel? There's an extra arrow pointing in the same direction. We're going to call this one C. We're going to call this one D. And I know that this angle here is 6y minus 3. Let's be good about this, degrees. And this angle down here is 129 degrees. Can I find the measure of y? So what is y equal? All right, so the big question is, are these two angles congruent? In which case we're going to set them equal to each other, or are they supplementary? In which case we're going to add them together and get 180. So this one's at the top left of its intersection. This one's at the bottom right of its intersection. They're not corresponding. Oh, but top left, bottom right, they're alternate and they're both outside. They're alternate exterior angles. And according to Theorem 3.3, alternate exterior angles are congruent, which means we can say 6y minus 3 equals 129 degrees. And then we can go into the time machine and do some algebra 1. Let's add 3 to both sides. That would be 132. And then let's go ahead and divide both sides by 6. 6 goes into 13. I'm going to give myself more space. 6 goes into 13 two times with 1 left over. 1 left over means 12. So 6 goes into 12 two times. And y is equal to 22. Now, we don't need to put a degree because y is just part of the degree there. So we actually use the theorem to solve an algebra equation. Okay. All right, last one that I'm going to do, and then you're going to move on to number 2. So I will do now page 133, number 1, and then when I'm done, you will do number 2, and make sure you watch to the end of the video. All right, so we have a transversal like this. We have two parallel lines like this. And we still have our angles looking like this. 1, 2, 3, 4, 5, 6, 7, 8, just for consistency. All right, so number 1 says that the measure of angle 1, they are giving us the information, giving us the information that the measure of angle 1 is 105 degrees. So they want us to find the measure of angle 4, okay? And notice, kids, I am listing the things that they're telling me to do. There's a lot to do. So I'm going to write measure of angle 4 equals question mark because I need to find it. Measure of angle 5 is equal to question mark because I need to find it. Oh, and the measure of angle 8 because I need to find it, question mark. And we need to tell which theorem we're going to use. We can use shorthand before Mr. Mitchell. All right, measure of angle 1 is 105 degrees. So the measure of angle 4 is also 105 degrees, and that would be vertical angles. The measure of angle 5 is also 105 degrees, and that would be what? Let's see. Top left of its intersection, top left of its intersection, corresponding angles. And then finally, the measure of angle 8 is equal to out there, 105 degrees because they are alternate exterior angles. Okay? A lot of vocab, a lot of visualizing. Give yourself the chance to process the information. You're going to do page 133, number 2 right now. And if this is on Edpuzzle, you're going to enter it on Edpuzzle. Make sure you get to the rest of the video.